Hello, Chem 1. Hopefully everybody is healthy, safe, practicing your social distancing, and now, according to Governor Hogan, out there wearing your masks whenever you're out in public. Today's video is going to be broken into two parts. It's all about how to balance equations. We're going to talk about why you want to balance equations, and then we're going to do a lot of practice problems to show you how to go about balancing equations in different formats. So first and foremost, first things first, what is a balanced equation? Well, a chemical equation is one like this, where we were talking before about magnesium reacting with chlorine to give you magnesium chloride. And this looks a lot like one of our synthesis reactions where Mg plus Cl2 gives you MgCl2. And we know that Cl2 is necessary because we know that chlorine is a Brinkelhoff. Chlorine is one of the diatomic elements. And the diatomic elements, again, to help you remember, is Brinkelhoff. B-R-I-N-C-L-H-O and F. Brinkelhoff. All these, when they're in a formula and they're by themselves, they get a subscript of a 2. So chlorine in this situation has a subscript 2. Another example of a chemical equation would be this: sodium reacting with iodine to give you sodium iodide. Now, you'll notice these two kind of both start off the same way with magnesium and chlorine and sodium and iodine, one element and then a diatomic, but their products are different. Now remember, the reason why magnesium chloride is this way is because magnesium is +2 when it's in an ionic compound, and chlorine is a -1. But sodium, being in column 1, is a +1, and iodine is a -1. So we have different numbers of the atoms in the compounds when we're done. Now, when we were doing synthesis before, maybe we might have been bothered by the example we had at the bottom, because for some of you who remember middle school time, this doesn't mesh with this. We don't have the same number of iodines on both sides of the equation. So this equation is not balanced. This equation is not balanced. The first one is, the second one is not. So why do we do balancing equations? Well, the concept is called conservation of matter. Matter in nature is neither created nor destroyed. It might change its form, but you're not going to have a change in matter. The matter is going to be constant from the beginning of the reaction to the end. So what that means is, when we're writing our equations, we want to make sure that we have the same number of atoms for each one of the elements on both sides of the equation. We can't just have atoms just appear or disappear. It appears in this situation here, for the second one, that we had sodium where there was one over here and there's one over there. But since there's 2 iodines on the left-hand side and on the right-hand side, we're missing an iodine. We're like, what the heck happened to this iodine? We're missing one. Something disappeared. It looks like an atom has disappeared. That's not an option. So we're going to show you how to balance equations, or remind you how to balance equations to make sure that we have the same number of atoms on both sides. So what we're going to use are numbers called coefficients. Now, in a balanced chemical equation, when we write our balanced chemical equation, we're going to put a number out front of the substance's chemical formula, and that's going to indicate how many of that compound you have. So, for instance, if I had the compound barium sulfate, BaSO4, I would have 1 barium, 1 sulfur, and 4 oxygens. But if I put a 2 out here, 2 out front of the compound, that means I have 2 times everything inside this compound, which means now I have 2 bariums, 2 sulfurs, and 2 times 4, or 8 oxygens. So the number out front multiplies through everything in the compound, whereas this little subscript number only multiplies through the number that's directly to the left. Okay, so let's see how this works. So what are we going to do to balance an equation? Well, first thing we're going to do is we're going to write the equation in its skeletal form. We're going to change the word equation into a chemical equation, or something that looks like a chemical equation. where we're going to start writing the compounds instead of in words. We're going to write them in formulas, making sure we write our formulas correctly based on what we learned a couple weeks ago, or actually that was like right before we went away on this Corona break, where we had to learn how to write formulas, ionic compounds, covalent compounds, acids, all that good stuff. And then we're going to put pluses and arrows in between. And on the left-hand side of the reaction is going to be the reactants. And on the right side are going to be the products. And in between is going to be this arrow sign. But we saw this in our examples of reaction types in the last week's worth of work. Then what we're going to do is we're going to go through and we're going to put our coefficients to make sure that everything balances out nicely. Going to make sure we can only change coefficients. So let's try this. Here's an example. We have methane reacting with oxygen to make water and carbon dioxide. So they gave us methane. So methane is CH4. It's going to react with oxygen. Oxygen is diatomic. It's O2. Now that's going to make, so we're going to use our arrow to indicate the making or the creation. So it's going to make water, which we know is H2O, and carbon dioxide, which we know is CO2. Now, when we balance equations, we want to make sure we have the same number of atoms on both sides. So what I'm prone to do, especially early on, to show you how this works, is we're going to try to visualize what these molecules look like. So CH4. CH4 is a carbon. And for the carbon atom, I'm going to make it red. Okay. And around it are 4 hydrogens. I'm going to make them white. So put one there, one there, one there, and one there. So they're attached. Guess I could do a better job of that. Let's see if I can make these attached. Oh, that's terrible. Let's get rid of that. Okay, so let's try this one. I'm going to put other hydrogen over here. There we go. And then oxygen. We need another color for the O's, so I'm going to make the oxygen. We'll make that one blue. It doesn't work real well with this background, but we can make this work. We're going to make it blue. Now notice there's O2, so there's 1, 2, and they're connected together. Okay. Now we're going to make, now let's see what colors we chose. We chose oxygen to be blue, so we're going to go ahead and make that a blue blob there. And attached to that blue blob is 2 hydrogens. So we're going to go ahead and add 2 hydrogens. 1, 2. Okay. And while I got my white marker, let me go ahead and fix up these hydrogens over here because they got to be a mess. There we go. And then carbon dioxide. Carbon dioxide is carbon with 2 oxygens. Well, our carbon, the color we chose for carbon was red. So I'm going to go ahead and make, I can get it to go over to the red. I'm going to make a red blob for my carbon. And then I'm going to attach to it 2 oxygens. Now my oxygens are the blue ones. 1, 2. Okay. So now let's look what I have here. This is kind of the obvious reason why this doesn't work. I have a red one red one on each side. I have 4 white ones on this side, but I only have 2 on this side, on the right-hand side. And for the blues, I have 2 on the left-hand side, and I have 3 on the right-hand side. So this is definitely not balanced out. So I got to fix that. But here's what the deal is when we're doing balanced equations. We can't just add random atoms. We have to duplicate the molecules that we have. So let's see what that means. Let's see, hydrogens. I have, of the white ones, I have 4 hydrogens on the left-hand side, and I have 2 on the right-hand side. So if I duplicated this molecule, and right now I have the blue marker so I can do this. If I duplicate this molecule, write it all over again, a blue, and then I get my white marker out. And I get my white. Now I have 4 whites and I have 4 whites. I have 1 red and 1 red, 4 whites, but now my blues are messed up. I have 1, 2, 3, 4 blues, but I only have 2 over here. So I need 2 more blues. And luckily for us, that blue, that compound comes out as 2 blues. So 1, 2. Now look at this. I have 1 red on each side, 4 whites on both sides, and 4 blues on both sides. This equation is balanced. So when this was balanced, it took 1 of the methanes. I need to have 2 of the oxygens, 2 of the waters, and 1 of the carbon dioxide to make it balanced. That's an example of a balanced chemical equation. To make the statement again, we're not allowed to change the compounds, but we are allowed to duplicate them in order to figure out how many of each of the compounds we need. Let's try another one. Okay, so here's another example. Hydrogen reacts with oxygen to produce dihydrogen monoxide. Okay, so we should know, again, this should be a little bit easier, that hydrogen is H. Oops, that didn't work. I'm going to try a different color. Hydrogen is H. Oxygen is O. And we know that dihydrogen monoxide is just water, H2O. So what's wrong with this? You're right. Hydrogen is diatomic, and so is oxygen. Remember Brinkelhoff. BRINCLHOF. Brinkelhoff. Whenever you see any of these by themselves, they get a subscript of a 2. Both hydrogen and oxygen are Brinkelhoffs. Now this isn't balanced. How do I know that? Well, let's do them tally. I'm going to do the tally as opposed to drawing these things out. I have on this side hydrogens, I have 2. And on this side, I have 2, and that's good. But oxygens on the left-hand side, I have 2. But on the right-hand side, I only have 1. So I need to balance that. So I need more oxygens. The only way I can get more oxygen is to have more waters. I can't just add an oxygen. That's a no-no. I can't just say plus O and I'm done. I can't add atoms. I can duplicate atoms, but I can't just add atoms. So let's get rid of that since we can't do that. It would be so much easier if we could, but we can't. So we want to duplicate. So let's see. If I duplicate this, I make there be 2 waters. Now I have 2 oxygens. That's great. But look what I also have done. I've messed this up. I've now got 2 times 2 or 4 hydrogens. Again, that's okay, because if I put a 2 out front here, now I have 4 hydrogens, 2 oxygens. Everything's good. Everything's balanced. Life is dandy. It's balanced. I have a balanced chemical equation. So balancing equations requires a little bit of practice. Okay, let's see if we have time for one more. Let's try this last one for this video. So we have aluminum hydroxide reacts with sulfuric acid to produce aluminum sulfate. So pause the video for a second, maybe a few minutes, and write the formulas for all of the compounds: aluminum hydroxide, sulfuric acid, and aluminum sulfate. Go ahead and pause the video and do that. So how'd you do? Let's see. Aluminum hydroxide, aluminum Oops. Do this. Aluminum. Did I lose my cursor? Sorry about that. Aluminum is Al with a +3 charge, and hydroxide is OH with a -1 charge. So I need 3 aluminum hydroxides plus sulfuric acid. Did you remember sulfuric acid was HSO4? Do you remember that? Aluminum sulfate. Aluminum +3. Sulfate -2. 2, 3. And water. What type of reaction is this? Did you say double replacer reaction? If you're on the Flex chat, you also know another type of reaction that says this is an acid-base neutralization. Good job. Okay, so if you got those right, let's try balancing this equation. Now, we need a few pointers with this one. This is one of these where I'm going to tell you there's some tricks to the trade. So let's first do our initial tally. Aluminum, oxygen, hydrogen, and sulfur. There's our 4 elements. Let's count. On the left-hand side, we have a total of 1 aluminum, and on the right-hand side, we have 2. On the left-hand side, this could be a little complicated. We have 3 oxygens here, plus another 4 for 7 oxygens. On the right-hand side, we have 12 oxygens here, 3 times 4, 12, plus another one for 13. Hydrogens. We have 3 hydrogens here, plus 2 more, that's 5. And hydrogens over here, we only have 2. And then finally, sulfurs. On this side, we have 1, and on this side, we have 3 times 1, or 3. So this reaction, as far as being balanced, is really, really messed up. But that's okay. We're going to go ahead and fix this in turn. Now, I'm going to offer a strong suggestion. This is my trick of the trade. What I want to say is, if you have a element that's quote-unquote all over the place, like oxygen is here. Oxygen literally is in every single compound. What I'm going to do is I'm going to make a point to do this one last. I'll wait to the end and do that one last. And the main reason for that is that's going to be a pain to fix. I got sets of 3, sets of 4, sets of 12, sets of 1, and that's just a mess. I'm going to do that one last. So let's take care of the other ones in turn. So first one I'm going to check, first one I'm going to fix is I'm going to fix my aluminum. So let's say aluminum. Aluminum, I have 1 on my left-hand side and 2 over here. So if I put a 2 out front here, then I'm going to have 2 aluminums. Now I've also messed up my oxygens and mixed up my hydrogens, but I know I've taken care of the aluminums, and I'm going to take a second to just chill a little bit and not worry about the oxygens and hydrogens just yet. I know I'm going to do those later on. Let's take care of the sulfurs. Sulfurs, I have 1 on this side, and I have 3 over here. So if I put a 3 here, out in front of the whole compound, I have no idea why 3 always messes up. Put 3 out here. I have to cheat. Put 3 out here. My pen does not like the 3s, and I don't know why. Every time I do that, it gives me a weird huckleberry. And does it work? Nope. I'll put a 3 here. That means now I have 3 hydrogens. 3 sulfurs, and that's good. But wait, let's see what I've done here. I now have messed up my oxygens and my hydrogens. Let me count them up. On this side, on the left-hand side, I now have 3 times 2 oxygens plus another 12. 3 times 2 is 6 plus 12. I now have 18. That's not an 8. There we go. I have 18 oxygens. And I didn't do anything with the right-hand side, so I still have 13. What about my hydrogens? Well, now hydrogens, I have 3 times 2, or 6, plus another 3 times 2, or 6. So I have a total of 12 of those. Okay, so now I got to fix something. Now I said I was going to do oxygen last. I've already taken care of aluminum and sulfur, so let's take care of my hydrogens. Right now, hydrogens, I have 2 on this side, and I have 12 on the left-hand side. So if I put a 6 here, then I'm going to get 12. That life is good. So now I got to finally tackle my oxygens. See, I have 3 times 3 times 4 for 12 here, plus 6. So I actually have 18. And guess what? I'm now balanced. This equation is balanced with the coefficients of 2, 3, 1, and 6. So I'm going to pause the video at this point and go ahead and give you a chance to take a break. I'm going to do one more video of the same PowerPoint, continue, and we're going to try a few more. And I'm going to show you one at the end. It's a little tougher to do. I'm getting you ready for your assignments for this week with balancing equations.